Chia blockchain, famously created by Bram Cohen, 2017. I really like this picture. I didn't spend too much time looking for it, but I think it's actually pretty decent because it brings together a bunch of evocative images of what Chia is all about. It's got the hard drives, it's got a guy standing there with his pitchfork. Uh, Lucas, let's talk about Chia.
I'm definitely ready to talk about Chia. Um, we've been remiss in not having a broader conversation about Chia because we have listeners listeners who we have projects of Chia on, but we've never had, I believe, in the history of our discussions on FOMO, a broader conversation about Chia, why we are excited about Chia, what we see in Chia. So I'm ready.
So the first thing about Chia is it's much patterned on Bitcoin. So for anybody that's familiar with Bitcoin, there's a lot to be familiar with here. It's essentially a proof of work chain. So that idea that you've got in Bitcoin, where it's a blockchain and it has a consensus mechanism that's based on real physical stuff. So this is not proof of stake, it's not proof of authority. It's different from all the rest of the stuff that has come after Bitcoin because everyone was trying to carve out some space for themselves. Either you copy the thing and you make it an exact clone, or you're trying to find some new way of doing it. And a lot of the new ways of doing it were regressions back to things that have been done in the past. So Bitcoin has been known as an innovation because it solved the Byzantine generals' problem using proof of work. So when Bram Cohen set out to create this blockchain, he liked a lot of what Bitcoin had, a lot of what was there. And so sometimes Chia has been referred to as the place where the good ideas on Bitcoin have had a chance to thrive. But the one thing that Chia set out to do with how it did something different was try to solve the energy utilization problem. And that is that as Bitcoin has continually gone up in its hashing power, and this has been viewed as a strength of Bitcoin, Chia viewed this as something that wasn't necessarily desirable. It wasn't desirable to use so much electricity. And so it set out to use a different type of mechanism to produce consensus, and that was of using hard drives. So if you think about the consensus mechanism of Bitcoin as you're trying to solve a hard math problem and everybody's furiously out there using their computer to do that, and they're generating all of these solutions and then essentially just dropping them on the ground. Chia said, well, why don't we take a different piece of hardware, that being hard drives, and instead of after we've generated all of those hashes, throw them on the ground, let's store them to the hard drive so that the thing that you're going to do nominally at any point is you're going to check your hard drive to see if you have the correct solution. And if you do, then you look it up, you use it to make the block, and that's how you form the consensus. And there's some nuance in here of exactly how you can pull this off. So in Chia, it's not just hard drives, but it's also these entities called time lords. There's verifiable delay functions. There's some really, really deep tech that you can go down a rabbit hole into getting the full details on. And we're not in this video going to spend our time doing that, but you can think about it like this, where the basic idea is that the same hashing thing that you've done on Bitcoin, instead on Chia, you do it once, you store it to the hard drive, and then you're looking it up. And this allowed Chia to very much lean on minimum specification for how you could run these things at home. And that meant that you can run Chia on a Raspberry Pi. It was from the very beginning said, try to use your unprovisioned storage. So this is if you've got extra storage lying around, you could devote the that storage to the Chia blockchain, and you could just sort of run this in the background, and you wouldn't have to invest a massive amount of money into miners and rigs, but you could rather run this on e-waste and garbage, and that therefore it would be a greener chain. And that basic setup has somewhat morphed over time as people looked at Chia and they said, hey, there's some ways that you could actually use Chia's hard drives, couple it with GPUs, which had largely gone unused after Ethereum abandoned their proof of work mechanism using GPUs. And they started to sort of mash these two things together. And so Chia stopped being just a pure hard drive play, but then became hard drive plus GPUs. And the energy utilization thing changed a little bit. But recently, there has been a desire from the company that mostly shepherds Chia, and that's Chia Network Incorporated, said, this is not really how we wanted things to go. We want to swing back as much as possible towards hard drives. And so in recent months, we've heard of developments that will swing this back in the other direction of using uncompressed plots, and that the GPU part will still be a part of the chain, but hopefully will be lessened. And so this idea that hard drives and GPUs are somehow in the mix together, there's a green narrative around Chia.
And I'm very glad to see CNI focusing in some parts in returning to the uncompressed plots. And I know that there's been a lot of discussion, and we've talked here ourselves about Bitcoin's association or moving it in alignment with energy production sites, and the effect that that can have, and maybe a positive effect on the price of energy and the use of energy. But at the end of the day, I think we're going to see prices of energy going up around the world, and so I don't mean to knock Bitcoin, but just to address that narrative going on about how wonderful a thing it is to be able to move Bitcoin miners close to energy sources and take advantage of the lower priced energy times. That doesn't necessarily bode well for people in their homes or people who want to participate in a blockchain and add to consensus security. And Chia gives them that ability.
Yeah, it definitely affects the overall narrative of decentralization, right? If Bitcoin requires a large amount of energy to really, meaningfully participate in it, it sort of changes the idea of whether you could really be doing this out of your house or whether it's really worth doing at all. I want to try to avoid talking too much about Bitcoin because otherwise we're just going to talk about Bitcoin. So I'm trying to draw some comparisons here, right? And that's the thing that I think is useful because there's a lot of knowledge about how Bitcoin works. I think there's less knowledge about how Chia works. So I fear we could stray into this territory if we go too much down that direction. But it's definitely a point well taken on the decentralization front, because if you want mass participation, and we're not talking about hundreds or thousands, we're talking about tens of thousands or hundreds of thousands of people participating in the consensus model. How can you do that? If you're going to do that, it has to be a meaningful way that you can run this in your home, that it won't have a significant impact on your daily life. If the node that is running in your house soaks up all the internet or costs you a massive amount of uh, money in electricity, it's less obvious that you could just run that thing out of your home. But if it's using almost no electricity and it's having very little impact on your home internet connection, then you could more conceivably say, well, there could be some box that's in my house and it's just sitting there doing its thing, and it really doesn't affect my home, my family, whatever. It's not making a massive amount of noise. It's not generating a tremendous amount of heat that I can't make use of, that I would otherwise have to dispose of the heat in some way. This is what allows for a mass participation in the blockchain. And that's one of the things that really was desired from Chia, is that you have a strong sense of decentralization. The other part of Chia that's different from Bitcoin is who makes the blocks. This has been a criticism of Bitcoin, particularly in that when you're pooling on Bitcoin, it's the pool that makes the block. And on Chia, the one who finds the particular solution, or the farmer, in the words of Chia, is the one who makes the block. And this is a really important distinction, because if you had collusion in Bitcoin amongst the big pools, you could start to have a problem. And so Chia viewed that as an issue from the very beginning and said, if we're going to have pooling, it's got to be the farmer that makes the block. The rewards of the block production go to the farmer. And so there's a strong economic incentive uh, baked into Chia from both its pooling protocol and from the way that blocks are produced that tries to address some of the fundamental issues of what's going on within Bitcoin. There's one other thing that I think is a major consensus or economic part of how Bitcoin works, in that there is a schedule for how Bitcoin reduces its block reward over time. It's been referred to as the halvenings. And so we've gone through a couple so far in Bitcoin. We've gone through one in Chia, but in Chia, there is no end to the block rewards. So even though there is a schedule where the block rewards reduce over time, it has a thing called trailing emissions. And that means that there's always some block reward that happens even after almost all of the halvenings on Chia have gone through. And so there's this idea that even if there's not necessarily a robust fee infrastructure, that there would still be some amount of inflation on the chain, and it would continuously give rewards for producing the block forever. So there's always what's called trailing emissions on Chia.
And I like that. I'm glad that you mentioned the trailing emissions also, because that was also something I thought incredibly positive. It makes more sense for people to join the network um, if that supply is constantly increasing. Can we turn to the technology behind Chia, behind with
Yeah,
Chia Lisp and
yeah, yeah.
BLS?
Mm-hmm.
And you know much more about. I mean, I can say Chia Lisp and BLS signatures, but um, you've been a developer on Chia, or are a developer on Chia. Can you talk about the improvements of especially Chia Lisp over the language on Ethereum, Solidity, and other blockchain languages?
When Bram set out to create this blockchain, it was during a time where Bitcoin was still viewed as a place where you could develop, you could create new products, you could do things with Bitcoin. It was the right near the time of Taproot, and when we were starting to get SegWit integrated. So these technologies made Bitcoin a bit more programmable. And this period of time was when we were heavily experimenting with how blockchain programming could work. And the divergence was that Ethereum came out and it was using an account model and it was using Solidity. And Solidity was a very approachable language for many developers. And so there was a lot of stuff that was built on Ethereum, but it ended up being that what was built on Ethereum had problems with it because anybody could make the code for what was running on top of Ethereum. It also meant that a lot of the code that was being developed wasn't really that good, and it was really hard to get it right because Ethereum has side effects and it's got state, and a lot of those things are not conducive to programming onto an immutable blockchain. You can kind of think about Ethereum as a database that sits on top of the blockchain, which itself is a database. So it's kind of like putting a database inside of a database, and it's got a lot of weird things that can happen with it, and ended up that Ethereum was very hard to get right. It was very hard to program it securely. So the language that was selected for Chia was Lisp. And so we've made comparisons between Chia and Cardano. And Cardano also adopted a Lisp-like functional programming language. And so this functional programming language that exists for Chia is called Chia Lisp. So it's a variant of Lisp. It's a functional programming language, and it allows for essentially free form. You can do anything you want on Chia. So whereas on Bitcoin, we have a scripting language. It's called Bitcoin script, but it's very hobbled. It doesn't have a full expressive capability. And so in recent months and years, there's been a very big cry to uh, expand the capabilities of Bitcoin. Whereas on Chia, there's really no need to expand the capabilities on Chia because you can do anything you want. And therefore, it's referred to as a Turing complete language. And that means that all of the ideas that have been theorized around Bitcoin, from custody to doing things like making the ability to move massive amounts of coins around, are present in Chia, and you can do that as of right now. Like there's never been any limitations on Chia. And Chia Lisp, since it's so expressive and it has so much capability, it's allowed for the creation of a lot of the stuff that the Bitcoin community has wanted to create for a long time, including asset tokens, NFTs, and doing these things all in a way that is durable. So Bitcoin has had the chance to create some things like ordinals and NFTs, and it's a shadow of what you can do, because these things are all very fragile. Like when you create something like that on Bitcoin, you can errantly destroy what you created by spending it in a way that you hadn't anticipated. And there have been protections that have been put on the client side to protect against this, but nothing fundamentally protects the on-chain entity from this. And that's usually referred to as covenants. Like if you have a covenant, it means that it protects the particular asset from being errantly transformed into something that it wasn't supposed to. It is an enforcement of the rules around which that particular thing was created. And Chia has had this from day one, and that meant that this idea around making an asset token, or in the early way that Bitcoin described these were called colored coins. It was a way to take a coin and put some particular markers on it so that you could have this thing. You give them $100 bill, they give you some money back for you get the goods, and then you get the remainder of whatever you didn't spend. So in Bitcoin, you have to do it this way. You always have to manage your change back. You always have to manage the coins that are coming back. In Ethereum, you spend whatever you want, and you don't have to worry about what coins you have, what's in your wallet, because you don't really have a wallet. What you have is some accounting of the amount of money that's assigned to a particular address, and that's done within the smart contract that it has been created. And that smart contract has usually some amount of centralization to it. Like somebody created it, somebody has control over it, and oftentimes there are some specific functions in there that allow for administrative actions. In Bitcoin and in Chia, this is not the way that the assets work. Each asset has its own special set of rules that's governed, and it's governed within the specific coin, and you have one. So it may be possible to do some of these more weird things where you can do administrative stuff to the coin. That's not the way that the programming has been done on Chia. And so each coin that you have has its own set of rules. That's that covenant that I was talking about. So if you have one of these particular coins that has weird rules that sit on top of it because of the Chia list that's associated with the coin, those rules are established on each coin, and the coin itself holds the rules, and that's what a covenant means. So yes, essentially what you're talking about is you have rules on each coin, that those rules are enforced for the coin, and it's allows for what looks like more direct ownership of things, because you're not renting space in somebody else's sandbox, but rather you have your own stuff, and there's just rules that are associated with the stuff that you're in control of.
And when you say direct ownership, it brings to mind a word that I hear a lot in the Chia community, and that's custody. And can we talk about custody, and maybe can we open that conversation with what BLS signatures are, or we can go directly into custody. But
Yeah,
we
they're
haven't
kind
we
of they're
haven't
kind
talked.
of they're kind of distinct. Like the signature technology has a lot to do with the underpinning way that you actually cryptographically prove that you have something. That's the BLS signatures, and there's a lot to be said about how the signatures work on Chia, and some of the particular properties that are very useful and how they enable you to do stuff. I'd say that that's probably a pretty advanced topic. So for an introduction, I would say uh, the reason BLS is interesting is because it has a whole bunch of properties that the signature technology on Bitcoin doesn't have. And so it allows you to do some pretty interesting stuff. But the where you find that to be useful and how that ends up playing out, it's pretty deep inside the weeds. And what it really allows you to do is do some pretty advanced stuff when it comes to multi-sig, when it comes to the composition of signatures and what you can do with it at a fundamental level. Um, I'd say it enables custody in a way that's more difficult on other chains. So it's more natural in the way that it's done on Chia. And so I'd say it's part of that enabling tech. It's like if you had a chance to look backwards at Bitcoin and say, how could we improve on it? One of the things you'd probably consider is what is the signature technology that you're planning on doing? And even if you look at Bitcoin signature technology, it's been noted that it's deprecated as of 2030. You know, the NIST standard says you really shouldn't be using this signature technology post 2030 because it has inherent weaknesses that are likely to be exploitable by that point. So BLS, I think, isn't on that same list in the same way, but we're all looking at signature technology, you know, with the eye towards what might happen with computing and technology into the future in just a little bit. So BLS is like an enabling technology that's pretty advanced, and it allows for things that you would probably want to do that would be pretty hard to do it in any other way. Moving to custody, what we usually mean by custody is you have control of it in a way that is within your own hands. The difference between self custody and having a custodian take control of what you have is the difference between having a jar full of coins in your house versus having some money in the bank. When you have some money in the bank is acting as your custodian. They have your money. And if you want it, you have to go get it from them or you have to ask them to move it around for you. If you have a bunch of coins in a jar in your house, you're in control of it. Yes, a thief could come in and steal it. So you've got a risk that self custody brings with it. But it also means that you don't have the risk that somebody is going to break into the bank and steal all the coins there. And then when you come to try and get your coins, they say, well, we don't have them. This is, you know, the fundamental difference. And in the world of blockchains, one of the things that we've wanted to do with custody is to try to make solutions where things are much safer, where you don't have a custodial risk, and then you also don't have a risk on yourself that you've somehow errantly screwed things up and that you've lost control of the coins in a way that you hadn't intended. A lot of what's gone on within blockchains is you have people errantly losing their assets because they're getting hacked or they're getting phished or things are happening. And so when people try to protect a large amount of assets, they oftentimes put things into a custody solution that requires multiple signatures. So even if one person gets compromised, you don't necessarily lose all the assets all in one shot. There are additional things that you can do when you have BLS and you have Chia lists that you can make really advanced custody solutions that aren't just multi-sig, but you can also put rules around how the coins that exist within the custody solution itself can get spent. That means that you can limit the number of coins that can get spent out. You can have these concepts of hot and cold storage, and they can be bundled together in a way with specific rules. And so custody has been viewed as a weakness of blockchains for quite some time because what we've been doing is we've got these 12 words or 24 words, and you have to be really careful about those that seed phrase because it essentially is the thing that it controls how your coins move around. But that's not the end of what you could do. And so this is usually what's referred to as custody is you start to put your coins into a certain state where you would have to have multiple people with those with different seed phrases. And if you wanted to move any particular asset, you would need two signatures of three, or you would need 5 of 7, or something like that. This is what we refer to as custody and advanced custody, is where you have more complex rules around how coins can get spent. You can't just get somebody's 12 words and then you can rug their entire bag. You can't do that if you have your coins that are protected within a multi-sig.
And also, you ostensibly, if you're the controller of those various signatures that have control of coins, you can, uh, if you can also recover your lost coins. I've heard Gene speak of that possibility too. Is that true?
I I mean, there's nuance within that. Once coins have been moved, Chia has finality just like any other blockchain. It means that once something has been spent correctly according to the rules that are associated with a particular coin, it's irrevocable. But within Chia, there are ways that you can do certain kinds of coin spends that can have rules that say, I'm going to give myself a grace period around it. So you can do things that I would refer to as like an escrow spend. Okay. So in normal banking, if you, I don't know, wire some money to the wrong person, there's a ability to go to the bank and say, "Whoops, I made a mistake. I errantly wired this thing to the wrong person. Could you please reverse this transaction? And I'll tell you the right person that I really wanted to send it to." And that's possible, and that's referred to as a clawback. And there are a variety of different situations under which clawbacks can occur. Bankruptcies. There's certain types of criminal proceedings where money can be clawed back. And this has been baked into the banking system for quite some time that they've wanted to have these rules. Blockchains traditionally have not had this. Like in Bitcoin, when you spend some Bitcoin and it goes to somebody else, it's gone. There's no way to sort of get anything back. In Chia, you can do a very special kind of coin spend where you can say, there's a certain amount of time under which I'm going to be able to still spend that coin. Like I'm spending it to a person, but I'm giving a time frame under which I could spend it back to myself and remove those rules. So I could send some coins to you, and as long as some small amount of time has not elapsed, I can still spend it back to myself. And that would give me some time to look at it and say, oh, I made a mistake. I copied something from the wrong spot, or I had some kind of a user error that didn't allow me to properly do the transaction the way that I wanted to. And so this clawback spend that exists inside of Chia is because you can formulate this kind of stuff in Chia Lisp. You have a way to put a time lock on the spend. You can say, this is who I'm trying to spend it to, but I'm going to allow for some other entity to spend it during some particular period of time. But if the normal rules of that have expired, then you wouldn't be able to just go get it back. So it's all governed by Chia Lisp and however you've coded it up. And so this is one of the primitives that Chia actually put together, was this idea of a clawback spend. You could send some coins to somebody, they'd be able to see validly that coins were on their way, and then you could wait and let the normal time elapse, and then the original sender couldn't claw it back, and then at that point you could scrape those coins into a non-clawback coin without those rules on it anymore. And so all of this can happen. But I'd say, to really answer your question quickly, Chia still has finality, and that means if the normal rules have expired, there isn't a way to just go back and undo things that were done either wrongly or rightly or errantly, because somebody hacked you. You can't undo bad stuff that happened unless you're operating within the rules of the way that the Chia list was set up.
Got you. Are there other nuances of coin spins that you wanted to talk about, or can we talk about offers?
That's exactly where I was hoping to go next. So let's talk about that. So, an offer file in Chia is what in the world of Bitcoin some or they would refer to as a partially spent Bitcoin transaction. And what this means is in Bitcoin, when you have assets, you can have two parties participating in this where you're saying, I'm going to trade you some Bitcoin for some special Bitcoin, right? Like the ordinal Bitcoin. And so when you do that kind of a transaction, you're really going to have two parties that are involved because you're trying to swap two things, and you're doing it entirely within the chain. So we're not talking about a cross-chain swap here. Cross-chain swaps are a very particular type of transaction where I might have an asset on one blockchain and an asset on another blockchain, and I'd like to be able to exchange those in a way where the two parties that are involved in that transaction can know that they're both going to get what they expected, and either the thing goes through completely or it doesn't go through at all. And that means that you get that finality, but you also get something that's called atomicity, that it either goes through in total or it doesn't go through at all. So this idea of an atomic swap, that you have two people that are swapping an asset and it's either going through or it isn't, is the default setup and sort of baked into the DNA of Chia. Because Chia has this ability to have special types of coins, it can have these asset tokens, it can have these NFTs, it can have all these different types. And because Chia architected in such a way that everything is a coin and everything is enabled in a way that you can do this type of swapping, there is a technology in Chia called an offer. And what that offer is it's just like a partially signed Bitcoin transaction where you can have one party say, here's what I'm willing to trade, and puts together everything so that it's been signed correctly and that transfer would go through, but that that spend would only be valid if somebody did what they've asked for within the transaction. So let's say that you've got some asset token and I've got some regular old Chia, and I put together an offer file, and I've got that half of the transaction, and I say I will swap you, 20 XCH for your really cool asset token that you created that represents, I don't know, maybe some AI compute power or something like that, because I want to buy some compute power on that cluster. And that AI token is what enables me to go out and get access to your GPU so I can run my generative AI workload or something like that. I can put that offer file up there, and what it looks like is it looks like a bid ask in the stock market. In the stock market, I will oftentimes say I've got some money and I want to buy some Apple stock. And that's a bid, like saying I'm willing to buy Apple stock for, I don't know, $500 per share, something like that. And that bid, then what you need to do is you need to match it with somebody who has an ask, and they're saying, "Yeah, I'm selling Apple stock for 500." So if you can make a market and you can match up the buyer and the seller, then the transaction will go through. The one who wanted to sell Apple gets their $500 per share, and the one who wanted to buy Apple is getting their shares of Apple. So this is what offers are in Chia. Is it's this way to create these bid ask pairings, and what that means is that now the entire world is a marketplace. Now, because you can put these transactions together, any place that you could post some blob of text, you can now start to do exchanges. And this means that peer to peer exchange of assets on Chia, it doesn't require centralized exchanges. Like if I want to just sell something, I can just say, "Hey, I'm selling it," and you can announce it anywhere that you have the ability to put up just blobs of text. That means that any social media, any messaging platform such as SMS or iMessage or Signal or anything like that now becomes a way to exchange value. And this exchange of value is done without a custodial risk. You don't have to KYC with somebody. You don't have to send your coins into a centralized exchange and hope that that centralized exchange doesn't get rugged or that they don't trap your money away. Now you sort of have this ability to do peer-to-peer exchange, and it isn't just transferring of value, but it's exchange of value, and it's enabled by this technology that exists within Chia that is default. So you have this anything for anything offers that exists where you can exchange two types of value, and that's just baked into the DNA of Chia.
When I first discovered Chia, it was the offers that took me aback the most. And whenever I've wanted to impress people, I send them an offer file via text or on Signal, and I've had some I've had some very fun conversations with people who were amazed at this innovation of being able to exchange assets without the centralized exchange, which is also to the hardcore decentralized ethos that exists in Chia, and a beautiful piece of it. But I think this also is underpinning some of the things that CNI has been talking about with regards to open markets. We can really see um, a new not just get rid of the banks, but get rid of the markets whenever anyone can engage in that with a trustless environment. Um,
Yeah, it's leveling the playing field, right? Instead of having this idea that you have to have some massive amount of infrastructure around how to build an exchange system, we don't have to reinvent the stock market. We can just start posting blobs of text up. Now, it doesn't solve the problem of how do you know what that blob of text is supposed to mean and what is the correct price of stuff. So price discovery and knowing sort of what the current ecosystem of what's going on, none of that is solved by this. But what this does solve is it solves if two parties within the Chia blockchain want to exchange something, they don't have to go ask a middleman to help facilitate that transaction. If those two parties can agree on what they're trying to do, and that what they're trying to do is they've agreed on a price somehow. That's what I mean by price discovery. So if you know what something's worth and your other party who wants to make this trade knows what something's worth, and even if one of you is getting rooked on this deal, it doesn't matter if you've agreed on the price, right? You're agreed on what the price is or whatever mechanism that you found each other and decided that you want to do this. What you don't have is a risk that this agreement that you have is somehow going to be exploited by one of the other sides. Once you've agreed on what you're going to do, you can make an offer file. The other party can accept the offer file, create the opposite part of the spend, submit that to the blockchain, and that's going to go through according to the rules that were established by the person who put the offer file together. So if I say I'm, buying 3 shares of Apple for $500 per share, that there isn't some way that I'm not going to get my 3 shares of Apple. I'm definitely going to get my 3 shares of Apple, and you're definitely going to get your $500 per share. That is going to be enforced by the blockchain, and that is a very powerful thing that that really opens up the wide world of how you can trade things. So as we start to have things that are represented on Chia, this idea of offer files now makes it so that if you want to sell some stock, you don't have to go ask New York Stock Exchange if this is something you can do. You can just go find some buyer and you can sell whenever you want. And that means that the markets can operate 24/7, just like how the blockchain operates 24 by 7. You no longer have these constraints that middlemen have to be in between, even when you're doing asset exchange.
I think this is an essential part. We've talked about blockchains and tokenization of real world assets. This is one of the things that needed to happen. But Grant, we're rolling in on 40 minutes. There were a couple of other things I wanted to touch on. I don't know if you want to or not, but
Yeah, let's take a couple more minutes. Let's do it.
okay, great. Verifiable credentials and L2s. Can we briefly talk about them?
So these are both expressions in Chia Lisp. So both of the things that you're referring to, an L2 is a way that you would normally try to make things happen faster than the base layer of the blockchain would allow them to. And the most canonical famous example of this is the Lightning Network on Bitcoin. So Lightning Network has a way that you can spend some Bitcoin into a very specific state, and then once it's in that state, it is trapped there, and that means that it can now operate at a different type of rules. Like you can spend it faster. There's different ways that it can operate, and that's usually what's referred to as an L2. These are the layers of Bitcoin. So the Bitcoin base layer is referred to as the L1, and the layer that sits on top of it is where these trapped coins that originated within the base layer are now operating under different types of rules. And so you can think about that even like how the stock market works, right? The stock market opens at 9 a.m. and you can trade, and then it closes at 3. And during that period of time, there's all this stuff that's going on. And then you have these settlement periods where everybody's getting what they're supposed to. This set of rules that exists around how things can work, you can envision doing something like that on a blockchain where you say, all right, everything that's going to trade during this particular period of time has these special rules. And then at the end of the trading day, we're going to settle everything out, resolve it back to the chain. And that's where everybody is going to live. They're living on that base layer. So it's the way that you move the assets into a very particular state that is defined as the L2, and then it's the rules under which those coins are trading, and then resolved back to the main blockchain that is that second layer. So it's really facilitated by the scripting language of the chain that enables you to do something like that. And since Chia Lisp, it has the ability to create an L2 just like Bitcoin, and it can also do more innovative stuff. So there have been ideas about how to make more advanced types of L2s inside of Bitcoin. And since Chia Lisp is infinitely expressive, that means that you can make anything you want on Chia. And so this has been something that's been being worked on for like the last 2 years by Chia Network Incorporated, and it's anticipated that we're going to see some launch of an additional scaling network on Chia sometime in 2025.
Yeah, in the crypto world too, we hear a lot of uh, of associations made with crypto and gold or fiat or what have you. But I think it's also important to understand that it's the communication, it's the secure communication for passing around valuable things. And I like to think of Chia as the Linux. We have Swift payments, we have FedWire, we have the BRICS payment network. But here's an opportunity for us to have a shared public network that's able to communicate financial transactions. And L2s are layers over that can sync up with that transaction layer and transmit more transactions. But what about verifiable credentials? What is that? What are verifiable credentials?
So, verifiable credentials are oftentimes something that we talk about within the scope of digital identity. So, digital identity is a way that you can say who someone is, and you're using blockchain in some sense to facilitate that identity creation. So, you have a digital identity, and then you would say, associated with this identity, I want to say something about that identity, like maybe that they're over 18 or they live in France. These are the types of things that you might want to say about an identity. And that is a credential. So those would be the credentials that you would have. It's some type of assertion about a particular identity. And the verifiable part means that there's a way to use the underlying infrastructure to be able to trust that credential fundamentally. So that if you tell me that you live in France, I don't have to go through a bunch of extra procedures to convince myself that that's right. I can just look at the credential, and by looking at it, I mean introspecting it from a code perspective and from a signature perspective that allows me to look at that credential that you presented to me and know that it's correct. That's the verifiable part. Like I can use code to ensure that all of the stuff that you're saying meets the standards and the rules that are associated with the way that that credential has been presented and asserted. And once I've verified that you haven't tried to fool me and that it conforms to the rules correctly, that credential can be trusted. And so therefore, like let's say if I wanted to get rid of my bouncer at the bar, right? I maybe wanted to have some automated sensor that allowed me to do that. Maybe I walk up with my phone and it presents some kind of a challenge, and then it goes beep and it lets me through the door. And I want to do that because I'm over 18, and because the particular place I'm trying to get to is protected for only adults, and you shouldn't be anybody that's under 18 that's going through this door. Normally, the way this is done is you hand them your identification. The big burly guy stands there looking at the credential. He's trained in some various way to spot fake IDs and what have you, and either lets you in or doesn't based on his interpretation of whether you presented him with a reasonable credential and whether you pass the sniff test, right? If you look like you're the kind of person who is on the identification. So he's doing the verification process. Now, the other way that you could do this would be to say, present some kind of digital credential and have it machine verifiable. That's what we mean by verifiable credentials. And a lot of what's going on in the world of centralized exchanges right now is KYC. Like they're trying to say, you're not a U.S. citizen. So we're trying to say, well, the only way you could be not a U.S. citizen would be to have some sort of a credential, like a passport or a driver's license or something like that from a different country. And if you have that, then you're allowed to trade in this particular place. And they have an internal process where they're redoing all of the work of trying to figure out if this credential is actually valid or if you're trying to fool them. With a verifiable credential, you could just present that. They'd be able to look at it from a code perspective, and then they just let you into their centralized exchange because they verified your credential. So that's what a verified credential would be. It's associated with a digital identity. It's a way to verify some assertion about somebody, and it's using the blockchain as what's essentially a distributed trust mechanism. So because the blockchain is immutable, it has this property that it can enable for certain types of trust that in any other system is very hard to establish that because you need that immutability. You need that things can't change over time, and if they do change, and I have rules that allow them to change that you can go and you can audit the changes that have happened, and you can decide whether the changes that have been made are appropriate. And if they aren't, then you can say, well, I'm not going to accept that because it never should have changed and it did change. And because it changed, I'm not going to accept it. So the immutability of blockchains really enables a kind of very interesting piece of technology, and verifiable credential is a good example of that.
And when I go to the bar and buy a drink and flash my ID, the government, the driver's license bureau or whatever, they've issued me a birth certificate. They're the ones who are asserting my age. When it comes to verifiable credentials in a decentralized blockchain, decentralized identity, who who are the issuers of these verifiable credentials?
That's completely up to the particular individuals, companies, or governments that will be participating in the ecosystem. It's largely an exercise in who wants to do this. A credential would definitely have an issuer. It would have some person that has put this credential out there, and then it's up to the one who's deciding whether they want to accept it, whether they would trust that issuer. So you could envision governments doing this. You could also envision private companies doing this. I mean, this is very common, right? When a university gives you a degree, they're an issuer of a credential. They're saying, well, you have a Bachelor of Science or a Bachelor of Arts. That's a specific type of credential, and you oftentimes will assert that credential when you want to get hired into a job or when you want to try to prove that you have some particular skills or that you've been trained in a particular way. And so the issuers are legion. There are many of them. It could be as many participants as in the ecosystem as you could imagine. And so as blockchains are adopted for this type of technology, you'd imagine that there would be lots and lots and lots of issuers, like many. And it may even be where you have layers of issuers, like somebody builds a credential and then someone does something on top of that. So it's the question is whoever wants to, really, whoever wants to create one.
I can't believe you didn't bring up crowd surfing, or couch surfing, but crowd surfing too. That's all that I wanted, that I wanted to talk about. Was there anything else that you wanted to talk about with regards to Chia?
I'd say the thing that you really should know about Chia is it baked into the DNA is an ethos of decentralization and trying to make it so that there's a broad base of participation, both in the consensus layer and in the ability to participate in the ecosystem without middlemen. That that is the takeaway from Chia. If you're looking for decentralization, if that's the innovation that we're really looking to in Web3, it's baked into the DNA of Chia. It's the thing that is the guiding north star of like everything that's been done. It's the cyberpunk crypto ethos that most of the people who were the original creators and the people who have stuck it out over the period of time that it's been created. It's coming upon its 10-year anniversary of its inception from 2017, and it was originally launched in 2021. So we've been at this for a little while here in Chia, but I think it's still yet to fully come into its own. And many are speculating that 2025 is the year that Chia really comes into its own and gets a lot of attention. So I would say look for Chia this year. Many are anticipating that this is going to be a big year for Chia, and watch for those decentralization themes in almost everything that happens on the Chia blockchain.
All right, sounds good. Well, we'll keep an eye on it too, and we will bring back reports of developments in Chia. So, see you tomorrow.
See you tomorrow.